As we're using these exponent rules, particularly the quotient of powers, and you're subtracting the exponent of a numerator from the exponent of a denominator, no, reverse that, the exponent of a denominator from the exponent of a numerator, there will inevitably be times where you come up with a negative. For example, if I were to do, let's say, x to the second power over x to the fifth power, our quotient of powers says you do 2 minus 5, which would cause us to do -3 as our final answer. So what do we do when we end up with a negative exponent? It's not really a good idea to write an answer with a negative exponent. We want to make sure all of our answers are written with positive exponents. Just good math practice to have positive exponents. Much easier for us to work with than negative exponents. But how do we turn a negative exponent into a positive exponent? Turns out it's pretty easy. It's a pretty simple thing to turn a negative exponent into a positive exponent. All you do is, if you have a negative exponent in the numerator, you'd make it positive by moving it into the denominator. And if you have a negative exponent in the denominator, it's made positive by moving it into the numerator. Essentially, you're just flipping it. So for example, if I have 2 to the power of -4, this is the same thing as 2 to the -4th power over 1. So what I can do is I can just flip it, and my exponent becomes positive 2 to the 4th, but in the denominator. If it's already in the denominator and it's negative, like this 1 over j to the -4th, I do the same thing. 1 over j to the -4th, and I flip it, and it becomes j to the +4th over 1, which I can just write as j to the +4th. So that's it. If it's a negative exponent, I can make it positive by moving it into the denominator. If it's negative and it's already in the denominator, is move it up into the numerator, and that's how you flip back and forth between positive and negative exponents. Okay, so what do we do if we've got a problem that has a mixture of bases, some positive and some negative? Well, we don't have to flip the entire problem. We don't have to move all of it. You just move the things that have the negative exponent. So in this problem, we have x to the -4th. That clearly needs to be moved because it has a negative exponent. And we've also got z to the -6th. That also needs to be moved because it has a negative exponent. But the y to the 9th is fine. Y to the 9th is a positive exponent. I don't need to move that. So when I rewrite my problem, y to the 9th is going to still be in the numerator. It was positive in the numerator. I want it to be positive in my answer. I'm going to keep it where it is. The x has to move though. The x is going to come down into the denominator where it becomes positive, and the z is going to fly up into the numerator where it becomes positive. And there's my final answer. The negatives change from either the numerator or the denominator into the other part of the fraction, and that's what changes the sign. Now, the only time this can get a little tricky or has the potential for some mistakes is when we toss constants in there. And all you have to really remember is that constants are not attached to variables. So when I look at this problem, one of the things that I might want to do just to keep myself organized is before I start moving things around, I might want to circle or otherwise indicate the things that we'll need to move. Now, there are two different ways you can go about solving this problem. You can see that um, we've got things with the same base here. For example, we've got two things that both have p in them, and we've got two things that both have m in them. We could use our quotient of powers property and subtract those right now, subtract the exponents to just get one term. Or we could use our negative exponents property and move them from the numerator or the denominator, the m's I'm talking about, to make those positive. Either one of those is fine. Doesn't matter either way. The r's, of course, are just going to get moved. There's nothing to combine the r's with. So few things I'm going to have to deal with here. One thing I'm not going to have to deal with, though, is the 75 and the 15, because those don't have negative exponents. 75 doesn't have a negative exponent, and 15 doesn't have a negative exponent, so those aren't going to move at all. They will reduce, though. 75/15ths will reduce because 75 divided by 15 is 5. So I can reduce this to 5 over 1, or you can just do 5 if you like. That's fine. Let's go ahead and look at the p's. We've got 3 on top and 5 on bottom. So if we do 3 minus 5, we get -2. So that'd be p to the -2 power. Now, if you're thinking to yourself, could I do like 5 minus 3 and just put the 2 in the bottom? Absolutely, we could. Absolutely, that's a nice little shortcut. Let's look at the m's. So we've got -5 on the top and -4 on the bottom, and our rule says we subtract the exponents. So it'd be -5 minus -4. This is the same thing as -5 plus 4, which is -1. So when I add these exponents, or sorry, subtract these exponents, it's like I'm adding 4 instead of subtracting 4. I would end up with m to the -1st. And then my r is going to have to come up into the numerator where it becomes positive. So I've combined everything that I'm able to combine, but I still have some negative exponents in the problem. So let's go ahead and fix that. So the 5 is totally fine where it is. The r is totally fine where it is. I'm not going to rewrite the 1. The 1 is unnecessary. You can put it if you want to, but that 1 in the bottom is not necessary. But what is necessary is that the p has to come down into the denominator so that it will be positive. And the m also has to come down the denominator. I can write m to the first, or I can just write m either way. And this right here is the final answer. The only part of that that you may want to do in a different order, and I'll go back to the original problem. This is optional, but if you struggle with your negatives, you may find this to be a little easier, is to start off before you start subtracting anything. Start off by moving your negatives. So leave the 75 over 15, or reduce, leave the p's, and then start move this m to the -5th down, so m to the +5th. Move this m to the -4th up, make it m to the +4th, and then move the r to the 8th up, r to the +8th, and then after you have all positive exponents, then start subtracting. You'll get the same answer either way, but you may find it to be a little easier to make all of your exponents positive first before you start doing the exponent rules. It's personal preference. As I said, you'll get the same answer whether you subtract first and then move the negatives, or whether you move the negatives and then subtract.